Okay, let's try this again. I was going great guns on this. All right, your first problem that you're going to get on your mini lesson 12 is this. It's going to be a bend it like Beckham problem. So let me go to the slideshow. Let's play it from the current slide. All right, so there we are. And instead of soccer, you're going to have a baseball. And you're going to calculate the Magnus force. This is the coefficient of drag, okay? And for a baseball, it's going to be different, and I'll tell you what it is. This is the density of air. You're going to find out what that, and by the way, that density of air, that means that's how much pressure is pushing down on us. And it's one way is we find the density of the air. And it's a real thing. I want everyone to look at your thumbnail real quick. All right. Your thumbnail is about 1 square inch. On that 1 square inch, air molecules are bombarding you, are coming in bang, a bang, a bang, and bouncing off those things, doing that impulse thing at the atomic level and bouncing off, and they create a tremendous amount of force because there's so damn many of them due to in the air, and so therefore you're getting 15 pounds per square inch. It's like you got if you take bowling balls all over yourself, 15-pound bowling balls all over your body every square inch, that's how much air pressure is smashing down on you. That's why we can get things to spin and to move in those funny ways. All right? So then 0.223, the diameter of a baseball will be given to you. It's a little bit different than this. But some of you might be asking, well, how do I do that d to the third thing? Well, here's how you do it. D to the third, the easiest way. On your calculator, you might actually have a key for doing to the third power, but the easiest way for the soccer ball here, it's 0.22, and just multiply that 3 times. And I do everything like this in parentheses. Everything. All right. So that's how I would do d to the third power. Luckily, we don't have to have it in the division, so we don't have to worry too much about the parentheses. So what do I mean by the parentheses? Here's what I mean. When I go to this thing, I just like this is done, but I go ahead and multiply this all the way out because I can on my calculator hit a third key. And it's going 25 meters per second. Now you're going to be doing a baseball, so it's going to be thrown at 93 miles an hour, but you're going to figure out it's meters per second, which you guys are experts at by now, and all that. Okay, so that'll be the first question. All right, to get through. And so the overall thing that you're going to be doing is this. The Magnus force is equal to the coefficient of drag of the baseball times the air pressure, which is the same everywhere for the most part. I mean, it's different. And I mean, it can be different in Kansas than it is here, but it's very, very slight. So we just take the differences are very, very small. So we'll just take the overall rule is about 1.2 to 1.3 kilograms per meters cubed. Okay? And so we do CD times the diameter cubed, and this is how you do the diameter cubed up here, times the frequency that it's spinning, and that's in revolutions per minute, times its velocity. So the last thing so F is what is known as the frequency, and that's how many times it spins per second, frequency. And that's the revolutions per second. I said per minute earlier. I meant per second. Okay? So that's how you do the first, 7 problems. And then the next one, we're going to look at a Salvador Perez home run. All right? So out here on that.